begin here, what I want to do today, I want to start by just looking at blending and seeing how simple it is to get that to work and kind of what we need to work with to get that working. Then I kind of just want to play around a little bit with shaders, with opacity, see if we can do some particle effects, see if we can implement fog, look at maybe back-faced culling, just kind of see where this takes us. So to begin with, I just want to make sure that we all have a clear understanding of how we can get blending to work and experiment a little bit with that, and then just see where it goes from there. So there's one thing I want to do with my code that I would not recommend you to do with yours, and I'm hoping that it might help the videos to not freeze up every time I kind of run my program and start rendering something. So what I'm going to do is I'm simply going to add a sleep here, which is basically just a time in milliseconds that this program just basically leaves the processor. So something like 0.01, it's like 1/100th of a second, which means that after it renders, it'll just do nothing for a while, which I'm hoping frees up resources on my computer for the video to continue streaming. It's the only reason for this. I'm just going to make sure that this actually works and that we actually see kind of what our program looks like at this point. It'll mean the frame rate is lower, but not so insanely much lower. So this is what we were doing last time. Fairly ridiculous, but we can take some of this out, line it up nicely. The first thing I'm going to do is just let's go into main program here, into display, and take this loop here, just comment that out. And leave us with something to kind of start with, which is this textured sphere here, where we have two textures on it. One is the diffuse texture giving the color, the other is the specularity texture, which is basically white wherever there is sea, but black wherever there's land. So this kind of a bit stark, this contrast, but either way it looks cool. Not very realistic, but at least you can see how the specularity is only affecting the sea and the water here. It's kind of cool if we go someplace where we can look at places with a lot of rivers and things like that. Wonder how we can see South America here clear in the Amazon. Oh, never mind. All right, so that's what we have at this point. So in order to just get blending out of the way to begin with, or not completely out of the way, but just the idea of what we need to do for blending to work at all, we need a couple of things. To begin with, let's go into display and let's just take this sphere that we're drawing here. Another thing I want to do today as well is possibly end up with multiple shaders, switching between multiple shaders, just to simplify some of the things that we're going to do. So I'm going to call GL enable, GL blend. I think I talked about GL blending in class. It's GL blend. You would have figured that out fairly easily. I am also going to go below this and do GL disable. So this should only affect this sphere here. Then I'm going to call GL blend func, where I'm basically going to set the policy for how we multiply each of our fragments, the source fragment which we're making now, and the destination fragment which is already in the frame buffer. So for the source policy, GL source alpha. Source meaning, so the first one is what affects the source, and the source meaning the fragment that we're making now. And what I want to affect that is the alpha value of itself. Then I'm going to say whatever's behind it, I want to be multiplied with 1 minus source alpha. So it'll be a weighted average, or basically a linear interpolation of these two values, the source and the destination, using the alpha value of whatever I'm putting in now as the parameter. This, however, hopefully should change nothing in what we see. It slows it down a little bit, but what we're looking at looks exactly the same. Seeing as we have a full alpha value on all of this, it's not going to change anything. So we could do several things now. We could go into our shader and set up some kind of variable here, something like uniform float opacity, and just set the opacity explicitly. We could also say, I already have a diffuse value here which has 4 values. If we look into our shader class, we have set material diffuse here. There we have a color red, green, and blue, and then we have this alpha value here. So we're not really using that. We're just always sending 1 in there. So we could change it so we send a different alpha value here every time. Set material diffuse, we could add something like alpha, do equals 1, and then we can say we always send this alpha value here. So we can send a color and an alpha value into this, and then we can use that. So that's one way. Inside the fragment shader, I would then go ahead here and say GL frag color dot A equals material diffuse dot A. So that's the alpha value. RGBA, just like XYZW. So I'm hoping again that this compiles with our changes. Still no change, but this, however, means that I could now go in here and say, before I draw this particular sphere, I'm going to say, I'm going to send in the color, and I'm going to send in an alpha value of, let's say, 0.5. Hopefully this should translate all the way into wherever it is. Alright, so it's a little bit dimmer now. We're not really seeing anything. Well, when we go into certain angles, you can see these kind of errors here. And if we look closely, we can see in parts here kind of the backside of the world. However, this looks pretty bad because around here we have these kind of errors, right? Because the order in which we draw the polygons within this shape is affecting this. So in some cases we're drawing whatever's behind first, and then we can see it through. In some cases we're drawing it the other way around. So if we go above, I think we should be able to see kind of the rest of the world through there. Especially here, you can see kind of world through that. Anyway, so we have some kind of transparency. However, the boxes behind here, they should be seen through this, but they're not. So again, that's because of the order in which things are drawn. So if we do nothing other than just take this object and move it behind the boxes that we were drawing, there's something more that we need, right? We should have taken the textures and everything with them. So here, just keep this inside. So now we're drawing this last. I'm going to take this and print this out as well. Let's see if that changes. Okay, so now we can actually see here that we're looking at this box through the sphere. So this is kind of working a little bit better. Since we drew the box first, then the transparent sphere on top of it. So now we have a way to set up blending, and everything we need is enabling GL blend, and the blending itself is something that OpenGL simply does for us. We need to set a blend function to tell OpenGL how it should blend things together, and then we may need to make sure, since we're using the alpha value of the source, we need to make sure that glfraccolor.ae is set to some value other than 1. And that's everything we need. Now we can play around with blending all we want. I want to look at a couple of other things though as well. We have this specular texture here, texture number 2. But it might be just as interesting to go ahead and say, what if we take whatever we get out of texture number 2 here, and instead of using it as a specular value, we can use it as an alpha value. So I'm just going to say this equals that. If we're using textures here, I'm going to make a value here, let's say float opacity. So say equals 1.0 to begin with. Or no, let's have it equal material diffuse alpha to begin with. So that's the default. However, if we're using textures, I'm going to say opacity equals whatever from this texture. Let's say use the red value. It's a grayscale image that we're taking in there anyway. So I'm just going to take that grayscale image and I'm going to use the red value, since the red, green, and blue value should be the same. And now I'm going to take this variable opacity and say that's what I'm going to use for the frac color here. So let's see what happens now. Okay, so this is kind of the opposite of what I expected, or what I was going to do. Still, we can see that if we go above here, we're basically looking through all the land. The land has disappeared and not only become black, but we can actually see through it. It's going to be cooler if we do this instead. 1 minus this, which means that we're basically reversing the specularity map. So okay. Oop. So now we're looking at this and we see stuff through it. We can see the boxes like right through the places where there's no land here. But when the land covers it. Any questions or ideas regarding this? I have several ideas of how to go a lot of different places here, but it's fun if you have, like anytime any other stuff that I'm doing kind of clicks on an idea that you have, definitely let me know and we can see if we can get an effect.
Can you, oh,
Go ahead.
can you, this sphere,
Yeah.
you put photos on top of it and Earth on top of that, and gradually alpha the Earth out so you look at Earth being
So it kind of fades from one texture
to another.
to another. Yes, we could do that. Do you want me to describe how we would do that? Okay, one thing I actually want to look at first. I'll describe how we would do this. And if we have time, we can actually do it. So what I would do is I would take 2 textures here into my shader. So in this case, we have texture 1 and texture 2. We're using one for a specularity map. We could just as well use both of them as diffuse maps. And if you want this to happen over time, I imagine your main program would control that time. So somewhere in your update function, you'd be updating some time factor going from 0 to 1 over whichever time you like it. So you put some start time, you put some end time, you basically take your current time minus start time divided by end time minus start time, something like that. So you get a factor from 0 to 1. And then I would simply make a shader that takes this factor in here something like uniform float, basically texture ratio or something like that. You're basically just telling it how much of one texture you want to have and how much of the other texture you want to have. So since I'm not going to actually do this now, I'm not going to leave anything in here, then you would simply be able to say, I'm going to take whatever I get out of this texture times the texture ratio plus whatever I get out of this texture times 1 minus the texture ratio, and I set that to my material diffuse, meaning that when the ratio is 0, I only get Earth. When the ratio is 1, I only get Phobos. But everywhere in between, I'll get some weighted average of the two. So you can simply take whatever you get out of this function, multiply it with any factor you like, add it to whatever you get out of this texture, and then you're simply adding them up and putting them into your diffuse. So that's how I would do it. There's one thing that I'm going to look at. There's one weird thing here, seeing as we're suddenly looking at, kind of looking through this, right? Still, everything we see behind is very dim because we only have this one light. If I, however, go to the other side, okay. So if I go to this side, I can see the lands that are here well lit. If I, however, go to the other side, I can still see the lands in the same place well lit. It will make sense with the light coming from this side that the inside of the lands on the other side will be better lit. Does that make sense? But seeing as we're just using the normal to do the lighting calculations, when we're looking at the back side of something, when we're looking inside of the sphere, we're still using the normal that faces away from us, even though we're looking at kind of the back of that face. So something that we can do in order to fix this, in the cases where we actually want to see the back side of something, like how can we tell if a normal is facing more away from us than it is towards us? Like what vectors do we have?
Do you use a cross product?
Not a cross product. I can use a dot product, but between which vectors?
N vector versus
Okay, the n vector, the normal.
and the one that's in the U
The one that's
points back from your head where you're looking.
not necessarily back from my head where I'm looking, because I can be looking one direction, but I still see something kind of out to the right of the screen or left of the screen. But it would be the vector that's pointing from the vertex that I'm drawing towards the camera. Does that make sense? So if I have a vertex that's pointing, if you just draw this on a piece of paper, you can see this. I have the normal, and I have a vector that's pointed towards me from the vertex. If these line exactly up, that means the normal is pointing directly towards me. That would mean that I'm looking at the face that should be lit up by this normal. If they kind of differentiate one from another, they'll end up at 90 degrees. Then I'm looking exactly at the side of it. As soon as it goes over 90 degrees into an obtuse angle, that means it started to point more away from me than it is towards me. So if I take the dot product of the normal and the vector that's pointing from the vertex towards the camera, if it's an obtuse angle, then I'm kind of looking at the other side. So which vector do I have? And I actually need to change this a little, since I'm sending the H vector here. I'm sending the S vector, which is towards the light, but I'm never really sending the V vector, which is towards the camera. So we go into the vertex shader, and now I'm just kind of playing around here. I'm going to have the varying vector be V instead. This, however, means that I'm going to say the varying vector V equals this. This here I'm going to take out of here. So I'm just sending the V vector over, which means I have to calculate the halfway vector in the fragment shader rather than the vertex shader.
Would you just say that the Lambert is negative, then you're kind of facing the...
Lambert is taking a dot product between the normal and a vector pointing at the light. But I'm kind of interested in the vector pointing at the camera because I'm interested in, am I looking, which side do I see? So in some cases Lambert, is lighting up a backside, but I'm not seeing that backside, or whatever. So I'm going to go back to the fragment shader here. I'm going to say I have v underscore v here, so I'm sending the v vector, which is towards the camera. That means at some point here, I'm going to say, oops, like so. Now I don't have v underscore h. I'm going to make a new vec for h. I'm going to use v underscore v here, and I actually don't need to normalize this. But I'm going to do this before I calculate the length of h. All right. What I'm going to do here, though, is I'm going to say now I have v underscore v, which is pointing from the vertex towards the camera, and I have the normal, which is basically telling me where this face is pointing, which was v underscore normal. I'm going to take the dot product of these, and I'm going to say if the dot product of these is what? How do I know that it's an obtuse angle? If it's negative, yes, the angle is bigger than 90 degrees. So if it's smaller than 0, then what do I want to do? So I want to flip the normal. Okay, if I do something like v underscore normal, like this, -1, this would work, except it'll tell me that I can't change the value of a varying variable. So I'm going to have to make a new variable here. You can try this, and you'll get that error from the shader. So I'm just going to say vec for normal equals v underscore normal. But if this happens here, I'm going to say normal equals -1 times v underscore normal. Or we might actually do an else here. Take this here, put in the else, and just say vec for normal, like so. All right, so either it's flipped or it's not flipped. And let's see if this compiles to begin with. All right, this is some kind of error that is very likely because the shader didn't compile. We go looking here. Warning, 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 error, VH undeclared identifier. So yes, here I have to make sure I'm using this new vector H here, and here. And also I'm using normal instead of V underscore normal. So I have to make sure I'm changing these things. All right, so now I'm looking at, the lit side on the outside, but it seems that the same light has an effect here on the other side as well. It makes more sense like this. Go to the other side, and it's all dark. I'm going to add a little bit of fake ambience here into the fragment shader. So don't do this yourselves, but I'm simply going to take the diffuse, and I'm going to add something like 0.15 to it. Just faking a little ambience so that when I go to the other side, everything doesn't completely disappear. So it's just darker, but it's not completely gone. Anyway, now I can go to both sides, and they're lit on both sides, so I'm flipping the normal there. One other thing I can do here as well, so we can see that you can still see these boxes through. Another thing I can do, and in this case, you can see that there are errors here still, because using the blending, I have to make sure in which order I draw things. So this isn't going to work perfectly when I draw this sphere as a whole. I'd need something like splitting it in two and drawing whatever's further away from me first and whatever's closer next. It can get complicated. However, if this were an enclosed object, this kind of shows us that before we were drawing the sphere, or before we were just drawing the enclosed sphere, we were still drawing the side that's here, the side that we now see because it's partially transparent. But before it wasn't partially transparent, but still we were drawing everything that's behind it. So that seems like something we'd like to not draw. Right?
Yes.
Yes. Yes, it does. Okay. One thing that we're doing here, we're using the normal that we get sent in here to decide whether something is facing away from us or facing towards us. This isn't entirely correct because we can send whatever normal we want. This normal can be just some way we want to affect the lighting. So in truth, this isn't the actually true normal to the geometrical object that we have. But OpenGL has a way to calculate that. Before we look at that, I'm going to do another thing. So instead of flipping the normal when this is the case, I am going to let's just undo what we did here with a normal change, not with the H change. Take this out here. So we're just using v underscore normal again. What we're doing now is I'm going to say, if this is the case, if it's facing away from me, I'm simply going to say discard. And what this does is it takes the fragment and it simply stops the fragment shader. It returns from the fragment shader. It tells OpenGL, don't write anything. Don't write anything into the frame buffer. Don't write anything into the depth buffer. Just this fragment is not going to be drawn. Just to see what this looks like to begin with. Now I can still see through this, but the backside that we were looking at earlier is just not there at all. So everything that I was seeing the backside of is now just thrown away. It doesn't make sense now that I'm seeing transparently through this, but it does make sense when this is an enclosed object. However, we have a better way to do this. This is just us kind of looking at how these calculations work. Yes, if it's turned more away from us than towards us, I'll throw it away. And the effect that we get is basically this. That we can kind of not see the backsides here anymore. Let's see if we can go back to seeing the backside, and how far back do we want to go? Let's just go all the way back. Right, let's get this back in here and say this is material diffuse A. Like so. So I've kind of taken this blending thing out for a while, and I am going to just take this out as well. Okay, I got an error. Ah, because it didn't change the vertex shader accordingly. I guess the fragment shader now has, okay, cool. Okay, so for instance now if I just go into this, there's one thing I want to add again into the fragment shader, and that's my fake ambient plus 0.15. So at this point, we imagine that in a regular computer game or program, we don't want to be able to clip inside. We don't want to be able to kind of be like this inside of the objects, right? But right now, I'm going inside the object just to see that once I'm inside it and see the back faces of this, they're all being rendered, which means that when I'm here, the entire face that I see, or all the faces that I see are being rendered, but the faces that I don't see are being rendered as well. So instead of actually doing this in the fragment shader, like we did earlier, which means that a lot of the OpenGL pipeline actually runs before each pixel. Per pixel we decide that something is facing away from us rather than towards us and then discarding it. We'd like to be able to tell OpenGL if an entire polygon, if an entire triangle that you're going to draw is facing more away from us than it is towards us, I just want you to discard that entire thing. Make sense? So, I am going to, let's just do it here as well. Go ahead here and say, I'm going to add something which is called GL enable, GL cull face. So what I'm going to do is called back-faced culling. So I'm going to take all the back faces and I'm going to cull them. Culling them basically meaning pruning them away from the stuff that I draw. So I'm going to enable cull face. And after this sphere, oops, I'm going to disable cull face. So let's just stick that in here as well. So let's see if something changes if we only do this. There are more things we need to actually control this. Okay, this is strange, right? Because this was the side that used to be lit. If I look at this closer, it doesn't really look like the outside of the Earth, right? It looks like the inside of it. Because we're basically culling the wrong set of faces here. Can you see how we're looking at the inside of a bowl rather than actually looking? Go to this side. It's hard to see it sometimes.
Oh wow.
But if you look at it like this, you know, this is not. We're looking basically at the other side, rotating at the inside of this. Okay, so we switched on cull face, but it obviously didn't cull the correct faces for us. We can also do another thing. We can go inside it, as we did earlier. Basically find this, go closer. You know, I didn't clip inside it. I just went inside it like it's a bowl. Then I can go the whole circle around, and I can look at the inside of it. But if I back out, I'm still looking at the inside of it. All right. So, GL enable, GL cull face means we've enabled GL to do culling. Now we, however, need to tell OpenGL what we want it to cull and how we define those faces. First thing is, we can do call a function called GL cull face. And this can take three variables. GL front or GL back, meaning we want to cull back faces or cull front faces, or GL front and back. Let's see what happens if we do culling on GL front and back. It doesn't make sense to ever use that though, does it? To basically cull everything, regardless of whether it's a front face or a back face. Just everything that's sent in is thrown away. So that's exactly what happens. There's nothing here.
Since it's an option, is it ever used?
I haven't done research on that particularly. I don't know in which cases you'd use culling for front and back. However, front and back, like in the static pipeline, was used in other functions as well. You could, for instance, you could set diffuse and specular colors for the front face and set another set of diffuse and specular colors for the back face. We can actually look at that later as well, like looking inside it, and it actually renders in a different color. So then it would flip the normal and render the back face in a different color. But if you wanted to set everything for both the front and the back, then you'd use GL front and back. In this case, for culling, it doesn't make sense to use it. So let's go ahead and say I want to cull back faces. What's going to happen now is we still have this same problem here. We are still culling what we believe to be front faces and not back faces. So the reason for this is because when I set up this sphere class, I defined the polygons when I'm looking at their front face. Imagine me looking at them so the front face is facing towards me. I defined them clockwise. So first point, second point, third point is clockwise when I'm looking at it. And I can actually tell OpenGL which to use here. I can say GL, call a function that's called GL front face, and what I can send into it is either GL clockwise or GL counterclockwise. And for whatever reason in this version of OpenGL, it defaults on counterclockwise. However, I defined this particular polygon as clockwise. So by saying I want to cull back faces, and I define front faces as clockwise. Okay, so now this looks normal. And I can go around it, and it really feels like I'm outside this and not inside it. If I, however, go inside it, it just completely disappears. So instead of seeing the inside of it, like we did earlier, I go inside it, boink, it just completely disappears. And if we have, for instance, those boxes behind us when we do this, and then kind of go inside, suddenly the boxes are there. So I'm inside the sphere now, but I'm culling back faces so everything disappears. Makes sense? Another thing I could have done is I could have skipped this and done cull face GL front, because the default is GL back. But seeing as I defined them the wrong way around there, it'll give me the same effect. Like so. It's not very clear though to say I'm culling front faces when I'm actually culling back faces. Instead, it's a better practice to be clear here. I am culling back faces, but I decide to define front faces clockwise rather than counterclockwise. So I'm getting the same effect now as when I just discarded it inside the shader. Now let's go to the fragment shader again. Let's get this effect again here, where we set up a float opacity, or we can say equals material diffuse alpha. We use opacity here, but if we're using textures, we're going to say instead opacity equals 1 minus this dot some part here. Okay, so another thing we can do to speed up things here, since we can see that the opacity in this case is 0, the alpha value that we're going to set is completely 0, and we're using this particular transparency blend. If we imagine that that's the only type of blending we're ever using, we can say if the opacity of something is so small that we won't see it at all, we can just as well discard it, and then we might actually save OpenGL some rendering time by discarding early on in here. So the same thing as we had before. Using the discard function, but for a different reason, not because it's the back face we're looking at, but because this won't be seen at all anyway. We can do something like if opacity, we can either say equals 0, but seeing as often, yes?
Could you do this in the vertex shader instead, so it's not per fragment?
Could I do this particular opacity check in the vertex shader? It's hard to discard a vertex because one vertex, it's just one of three for the polygon. So discarding a vertex is something that's not really simple to do because it'll still have other vertices that it sends to the shader. So not really, or there's no kind of nice simple way to do that, to discard it. You can set it to something, set its clip coordinates to 0001 or no, that'd be the I coordinates. Never mind, you could set its clip coordinates outside the clipping volume, so it'll just be discarded after that. But you have to make sure then you do it for all the vertices in a single polygon. That's kind of tricky as well. So is that, you mean like, can I throw things away? Because in this case,
Or like simple shapes like a cube. Just remove the backside. Or something that has.
yeah, but using culling actually, if you're just removing the backsides, using culling is simpler. It's really difficult to try to throw away an entire polygon in calculations in the vertex shader. You can Google it. The answer you'll get, it's difficult. You can do some mixes like setting the clip coordinates to something that's outside of the viewing volume, but you need to make sure that you do it for all the vertices in a polygon. Anyway, if the opacity here, and that's the thing, what OpenGL does in the culling, it actually calculates the normal for a polygon. It doesn't use the normal that you send in. That's just a varying variable that we're sending in, or an either attribute or a uniform variable that we're sending in. OpenGL actually calculates the correct normal for a polygon before it makes this decision. All right, so if opacity is 0, or I'd actually do something like saying if it's less than some really, really small threshold, because in some cases you'll have some kind of anti-aliasing or decisions on how the texture is read. So if opacity is really, really small, we can simply discard it. We won't really see a difference here in what we see, but there will be a difference in the rendering time. I'm not sure we can see it in the frame rate, like in this case with something so small, but it can make a difference to discard things that you know won't be seen. So we still have the same effect. We have this. On the edges here is that blending is happening, but we don't have to do the blending on something that's completely transparent. Now we can possibly say we're going to multiply this like so, meaning that we can do two things. We can both have an alpha texture here, which decides like on a texture base, which means each polygon can actually have different alpha values for its pixels, obviously, because different colors of the texture end up on different parts of the polygon. But then we can also use the material diffuse. Where did we have that? To say I also want the entire thing to be only half the opacity that it otherwise would be. So now I can go here where you can see the cube behind it. So now it's completely transparent there, but also where the land passes over the cube, we can still see the cube through it. So it's also like semi-transparent there. More things with blending that we're interested in. So one thing, this is we've kind of gotten to this idea of billboarding, in that we have this texture and some of it is completely transparent and some of it is not. And we're basically using what we would call an alpha test here, kind of implemented a simple alpha test, which is saying if the opacity is beneath a certain threshold, we throw it away. We could also set a variable for the threshold opacity. And all of these things would always be making our shader more and more and more and more complex. we're going to add the ability to have an alpha threshold, and it's going to be an alpha threshold that we can change. So we need a variable for that, and we need all these different textures. And at some point, making a generic shader program like that is going to mean we have all of these different variables here for all of the different lights and all of the different thresholds and all of these different things, and Boolean switches telling us, are we using a specularity texture, are we not using a specularity texture, are we using an alpha texture or not, are we using a diffuse texture or not. It's going to become really complicated. So another thing that's often more simple to do is just say, I'm going to make several different shaders that do things in a certain way. So one thing I'd like to do now is I want to go ahead and I want to make something that I'm going to call a sprite shader. So it's going to be simpler than this one. This one has these different things that I can do with it, but I'm going to just make another shader here. So let's, I wonder if I can take these and just copy them. Okay, cool. Let's go ahead and rename these. Sprite shader .frag. Sprite shader. So I'm going to go into the sprite shader vertex shader. I still need the position. Well, a sprite is basically just an image that we put into our three-dimensional scene, but it's not really a three-dimensional object. It's not an enclosed object. It's just a single polygon or a single square, and we simply put a texture on top of it. So we're just putting that texture into our environment. So in that case, we don't even need to calculate lighting or anything. So I'm going to make this a really, really light sprite shader. I'm going to say I need a UV map here for it. I need the positions. I need a model matrix and a view matrix and a projection matrix because we're sending this into our three-dimensional scene. What we're not going to be doing is any lighting calculation, so I imagine we can skip all of these. That means we don't need the normal, we don't need any of these, we just need the UV coordinates. Let's see how I can simplify this even more. Okay, we don't need these or this or the normal. So yeah, we have local coordinates. We have at this point global coordinates. The UV will be sent into a varying. The normal is unnecessary. So we're just taking our vertex and doing geometrical transformations on it. And the fragment shader, okay. I want a texture. I probably want another texture because I want to be able to have an alpha texture as well. Using texture is more or less moot here. None of these are important. None of this is important. So what I want to do here is to say I can simply take this and say my diffuse is simply this. Specular is something that I'm not gonna do. I can actually just say this is just my color. My opacity will be my other texture. Well, okay. Let's say if we're using an alpha texture, let's just say float opacity always equals 1. But if I'm using alpha texture, so let's stick that in here and say uniform float that. Okay, so none of this. Opacity now equals this instead of 1. Well, for a sprite we actually might, using alpha texture, might actually want to have specific opacity as well. Uniform
Opacity.
float opacity and u underscore opacity. So we can do something like this. All right, so we have some options here. We can still have this this threshold here. All of this lighting is pointless because the only thing we want to do here is we want to say fragment color equals the color, and the alpha value of the fragment color equals the opacity. Okay, so we've made a really simple shader here. But now we need a way to kind of switch between these shaders, right? So this might get a little bit... Start by going to shaders here. And we're going to take our class in its entirety. Okay, so we're going to skip this. Okay, so there's a lot of things that we can throw out. Let's just start from the top here. We're going to use sprite shader .vert and sprite shader frag, and we're going to compile those. So we have our rendering program ID here. We're going to call this class sprite shader. So create the program, compile this. We need position, we don't need normal. So we're throwing that out. We need UV, we need the matrices. We don't need any of these. We're not actually allowing for a color here. That's okay. Let's just leave that to the texture. Material diffuse, specular, and shininess. We don't need. Okay, so using alpha texture. We had that here, right? Using alpha texture. What other things do we have here that we added? We have the opacity. Otherwise, we just have these things. So position and UV, 3 matrices. Oops. Let's throw this out. So we have position, UV, 3 matrices. That's everything we have in the vertex shader. In the fragment shader, we have 2 textures, opacity, and using alpha texture. So we have 2 textures, using alpha texture, and opacity. So U underscore opacity. No, not opacity. I'm just going to take this here to make sure I have the right name for it. Okay, so now I have this operation here, use, that will actually make some sense because we're saying use program for this particular rendering program ID, and we actually need to use this from now on. However, model matrix, view matrix, projection, not this, not this, not this, light, material, none of these, none of this, but position, okay, so I need just take these out. Attribute buffers with UV. So either we're just going to be doing position, or we're going to be doing position and UV. So that means we're going to start at 3 here. Using alpha. No, it's always going to be with UV. The question is it going to be... Okay, cool. Just always use this one. This, however, depends on whether we do this or not, and let's call this set alpha. Texture. Call this alpha texture location. So here we have this. Okay, going through this again. 3 matrices, these two. We have the matrices. We set our attributes, which are position and UV. Skipping this, we can set the diffuse texture and we can set the alpha texture. Is this super complex here now? All right, so now I'm going to go into base 3D objects here, and let's just make a new object. Let's just make it above the sphere here. Call it class sprite. It's going to be fairly similar to the cube. We could actually steal the cube class. Well, no, not quite. All right, let's just make it super simple here. Okay, take def init along with it. So let's begin here. So we're going to make this array, except I think it's best that we just set the... Okay. So these are going to be 3 points. Let's imagine we just have 0 in the z dimension here. So minus 0.5 minus, then we're go up, go over, then we go down. So I'm going to add to this the texture coordinates as well, which would be 0, 0 here. We went up, so that's 0, 1 here, 1, 1 here, and 1, 0 here. Okay, so now I have 5 coordinates for each vertex here. X, Y, Z, and U and V for the texture. Okay, so now I'm going to look at how we do this in optimized sphere after we finish this. So we make a vertex buffer ID, we bind the buffer, we send this array here into it, then we unbind the buffer, and we release this array. So what more do we need? We need a draw function. So let's steal that from here as well. Okay. So I'm going to make sure that we're actually reminded that we're going to be using the sprite shader here when we draw this. So our shaders here, where I have the sprite shader, I have set attribute buffers with UV. Okay, and the vertex buffer ID. There's no number here, no size. Nope, cool. All right, so with this sprite shader, we call this operation. And now we don't need to do all of this. The only thing we do is we do triangle fan, since we went around. We start at 0, and we're going to draw how many vertices? Anyone still following? 1, 2, 3, 4. I'll just draw all 4. So okay, a lot of things happening here. Now I just want to draw a sprite just to see that it works. So this is going to be tricky, or there's probably going to be a lot of errors. So let's just draw it last, after we do everything else, except the only thing I want to do here at the beginning, before I start doing all of this. So I'm setting the projection matrix, I'm setting the mu matrix, so I'm setting basically everything in the draw function. That's another thing, if we're switching between shaders, we need to make sure that we set every variable into the shader once we've switched, because we can't trust that OpenGL will keep track of the variable values that we had the last time. So I'm going to go ahead and do self.shader dot use, no, like so, and say now I'm using this shader, and then I set all the variables for it. I'm going to go ahead and say, when I make this self.shader shader 3D, I'm going to make another one here. Self.sprite shader equals sprite shader. This doesn't really matter, but might as well make sure that it's switched on once, just so we know that if there are any errors. So we make this shader, we switch it on. That means we've built the program, we've told OpenGL that the program is there, we've got the program ID, so now we can just switch it on and off anytime we want. If we want to look at this use function again, it simply calls this operation GL use program with the ID to the rendering program. The ID to the rendering program OpenGL gave us here in GL create program. So it gave us this ID, and then we use that ID in all the operations that we're telling OpenGL we want to do this and this and this. We're doing it for a particular rendering program. So at this point, our system has 2 rendering programs linked and compiled, but we only use one of them at a time. Okay, so we need to make sure here in our sprite shader that we set everything. We need to set the model matrix, view matrix, and projection matrix. Set the diffuse texture and the alpha texture. We usually do that per object anyway. And then this. So let's go back to display. So self-shader.use is called here before we do all of the stuff to the shader. At some point, however, we're going to go ahead and we're going to say, all right, now I want to start drawing my sprites. And the thing is, we can actually switch to this shader and then switch to the other shader and then switch to the other shader again as many times as we want. But I'm going to switch to the sprite shader now. That, however, means that we're going to have to make sure that we do all of these things. So I'm setting the sprite shader, but I'm also going to make sure that I don't need the eye position, I believe. We might need that for, well, no, we don't need to do the backface culling ourselves anyway, so.
But you have to rename to sprite shader.
Yes, thank you. Okay, so we're setting the projection matrix, we're setting the view matrix. We're going to set the model matrix when we draw something. So we might as well go ahead and do something similar to, well, let's just use the self model matrix. That's fine. Self dot model matrix. In some cases, we might want to use the same model matrix with some transformations that have been done, then pop those off, add a few, draw some sprites, draw some objects, pop back. We can switch back and forth in this. So self.model matrix dot add just translation to, I don't know where to put this. Let's say something like to begin with and see where it ends up. Model matrix dot add scale. Let's make sure it's big enough. 3, 3, 3. Then we have shader.setModelMatrix, as always. So now I have to want to make a sprite. So we have the sprite class already. I'm going to go ahead and say self.sprite equals base 3D objects. We had the class sprite. So we have that here. Yeah, and then we're setting the textures outside of this anyway. So let's just use one of the textures that we already have. Let's just use the dice texture here. This has become huge. Okay, somewhere we're setting a texture. Let's do this. Use this particular texture. I also want to go ahead in shaders and say, so set alpha text. Let's go ahead here and say, oops, if number is none, we'll set this to 0. So we can basically switch it off at the same time. Else, okay, so that makes sense. If I send none in here, I don't want any alpha texture. So I'm going to see if we can do that to begin with. Shader set diffuse texture this. Shader, this should be sprite shader. Sprite shader set model. Sprite shader set alpha text none. Alright, then at this point we should be able to do something like sprite shader use, set projection, set view, set the textures, self.model matrix. Let's do like we do in the other cases. Start with a push and end with a pop. And here, I guess we'd like to do self.sprite dot draw. I have a strong feeling that there are going to be some complaints from this, rather than it just working right away. Okay, here, local variable reference before assignment. Okay, so how did I do this here? Okay, yeah, I see. Let's just do it this way. Call this vertex area instead. Right. Using texture, we don't have that. We have using alpha texture. Do we have alpha texture? Yes, okay. Fine. See some more possible errors here. Missing one required argument. I need to send the shader in, right? So that's going to be the sprite shader. Okay. Self.sprite shader, thank you. Okay, so we're rendering something. Question is, are we rendering that sprite? Okay, now I need to figure out where the other things are and put it somewhere closer to that. Okay, where, for instance, is the original sphere? Translated to 300. Let's just put it in 050, something like that. Okay, so seems that it's not here. Let's just put it exactly in 300 here. Not matrix, sprite shader. Okay, I'm setting a projection matrix. I'm setting a view matrix. Setting some texture ID. Okay, what does the shader look like? Probably not using blending, so that should not affect it, right? Blending is disabled anyway. At this point, can anyone see particular places where we should? So sprite.draw. Okay, we're sending in this buffer. 1, 2, 3. Ah, okay. There's one thing I can think of. If we go into shaders, here, yes, this should not be 8 times, this should be 5 times the size of float, right? Because we don't have any normal in there anymore. Let's see if that's enough. Not quite. Go in here again. See if we can scale it even bigger. Z actually should need to be scaled. Okay, there's nothing here that's that size. So if we look at the shaders again, take the vertex buffer ID, 3 and 2, 5 times. This is, if we look at the other shader, three times and 6 times is where it starts. So I'm just going to be completely sure that, for instance, if I switch away from this shader, or that is, don't use that again, it should crash, or if not crash, then at least complain. Okay, so we are switching between the shaders. Here below, we're switching to the sprite shader, setting the projection, setting the view matrix. We are setting the model matrix. We're setting the color texture and the alpha texture. I wouldn't complain if someone has ideas on places to okay, this is normal. Okay, I never set U opacity, right? So if we go into shaders, so I have opacity location, but I don't have any operation setting U opacity, meaning that opacity is probably 0 by default, meaning that this will discard everything. So if we can simply take this out, that might be a possible. Okay, so here we have our sprite. But this, yeah, okay. This shows the need to make sure that we definitely set values to all the variables in the shader. Okay, so what we have now is simply a single polygon or a single kind of quad here that has a certain texture on it. So what we'd be interested in doing, I wonder if we can go and do something like leaf texture with alpha. Or actually, I'd be more interested in leaf texture and alpha texture. Okay, so we can, for instance, take this one. Okay, save image as. Okay, cool. Let's just say leaf color 1. Save. Let's take the corresponding alpha. Save image as. Leaf alpha 1. So we have leaf alpha 1 and leaf color 1. You can now go here and just make more textures. Of course, you can kind of make classes around this functionality rather than just constantly adding it to the main program. I'm going to keep doing this. So we have leaf, capital, leaf color 1, and then we have leaf alpha 1. Texture ID, leaf color, texture ID, leaf alpha.
Leaf alpha is a JPEG.
Okay, but which were they actually? Were they both JPEGs?
Oh,
You look over that.
Oh, yeah. Okay, leaf alpha, they're both JPEGs, so we have them both JPEGs here. So we should be able to load them. See that they load to begin with. Okay, cool. Now I want to go ahead. Okay, with the sprite to begin with, let's go ahead and say texture ID leaf color. And let's put this somewhere different. Instead of putting it right there, let's put it somewhere higher. 10 here, 3, -5. So now we have the same sprite. So okay, this is simply an image here of this leaf in 2 dimensions, but we can render 3-dimensional things like trees, and then we can look at them. However, obviously this wouldn't look good inside our scene. So instead we'd like to do something like, okay, I'm going to rotate this 90 degrees. Add translation, add scale. Let's add the rotation first. Rotation. Say around X, yeah, sure. Rotation X, 90 degrees, which is pi half. So now we come to the idea that is billboarding. I'm going to go above this here. And you can see that all the other things obviously are obscured behind it because we're just drawing this entire polygon here. So again, now we're going to go and say, now I want to do this same thing here, except I'm going to grab leaf alpha. I'm going to set that to texture 1. I'm going to set the alpha text to 1. I'm saying now the alpha texture is texture 1, and I've assigned texture 1 to read from this texture image. Okay, not quite. Probably took out all the opacity references. Okay, so now let's look at the shader a little bit again. Fragment shader for the sprite. So this is, yeah, I'm not using blending to begin with. So one thing we can do, let's just set the opacity to begin with. On here, and we're going to say self.sprite shader. Wait, we didn't even have an operation for that yet. So set opacity self dot opacity location. Oh yeah, I always write opacity wrong. Okay, so we're setting opacity here. Let's go in here and just set opacity to 1. So now I can add this into our shader again. Let's just make sure that something is happening. Wrong type. I had an I instead of an F. So it's a floating point number that I'm supposed to be sending in there. Okay, so left over from earlier, I'm doing this, 1 minus. But now we have an actual correct alpha texture, so we don't need to do that. We just take the opacity directly from that. So, okay, now we have our leaf here. However, you can see that we still have kind of white in the edges here. So we'd really like to get rid of that. Possibly, if we lower this threshold and just say if it equals 0, 0. No, then it'll actually become worse, I guess. Okay, so we have this white outline here. So there are things we can do here. We can tell OpenGL how we want it to grab a certain value, because it's kind of doing interpolations or doing weighted averages around pixels where a single pixel on the screen is kind of not right in the center of a pixel in the texture. We kind of take averages of what's around. So we can use, it's called min filter, mag filter. Search for that, OpenGL min filter. Not what I'm looking for. That's usually easy to, text parameter, yes, okay. Is there an example here? Okay, let's just GL text parameter usage. Okay, for instance, here we can use it to tell it if it wraps. I'm always stuck on these. I was just going to find a quick example. So target would be texture 2D. Name would be texture min filter and mag filter, and I guess we'd use the parameter GL nearest. Okay. So I am going to, before I draw here, GL text parameter, GL texture 2D, GL min filter, GL nearest, So this is one way of telling OpenGL not to kind of do averages. I'm going to see if this works right away. Okay. GL texture min filter, sorry. GL texture. Basically telling OpenGL that when it selects a color, it should not kind of take averages or take values from several different pixels in the texture. Okay, this is still giving us this line. But instead, what it should do is to just like pick the value of the nearest pixel. Okay, since we're still getting this, what would be nicer to begin with is if it were black around the edges rather than white, but that's still not a solution to our problem. One way is to go ahead in the fragment shader and kind of set this threshold higher to make this a little bit less. And another way is to not only do this alpha test. Okay, so now we've lost those edges, but another way as well is to add blending into the mix and also kind of blend the edges so that they don't become as harsh. But okay, so the alpha test threshold here, we can make that higher. If I make that really high, I imagine we're going to get we're going to lose some of the edges here. I can see that it's not exactly the same edges as we had before. So this is something that we can set just to make sure that our particular texture looks nice. So you can see that these are closer to the original edges. So now we have this billboard, and we can see that what was earlier, like around here, is actually the polygon that we're drawing. We can still see things through it because we're blending this, or basically discarding whatever has a lower opacity. If we go ahead and add blending as well, just going to steal that from up here. It was here. Enable blending before we draw the sprite. And then let's disable blending after we draw it. Let's make sure this works. Okay, so the blending doesn't change anything now, but I can go ahead into my sprite shader and now basically take these discard lines and skip them instead. And just say I'm not going to throw this away. Instead, I'm going to allow the opacity through the blending to do this. So now we basically get the same effect. We're not discarding these, instead we're blending them to the rest here. So this opacity, set that to the alpha, and then we blend it in. If we can actually just discard them, it's a quicker way to do this than to use the blending. But we can mix the two together. Go ahead into here and say, I am going to set the opacity of this leaf to 0.4. I'm also going to go in here just to save time, or save rendering time. And I'm going to discard it if the opacity is below a threshold. Otherwise, I'm going to set the opacity. The opacity will be this base opacity that I set times the opacity of the image. So in this direction, we can just see it as a little bit darker because there's just a black background behind it. Go above it, and now we have the semi-see-through leaf. It's also being discarded here on the edges, so on and so forth. So any fun ideas at this point? I know all of this takes a while for me to get to work because there's always a few places in the program where we have to change things. But just to recap, what we have now is a couple of things. For instance, we've made a separate shader. We're now using 2 shaders. The things in the background are drawn using one shader program, and the leaf is drawn using another shader program. And we're just switching between them as we wish. So we can use one program, draw some things, use another program. This means that instead of our shader having to have a bunch of if sentences checking, are we using a texture, are we doing this, are we doing this, I just made one shader, and it's insanely simple. It does almost nothing. It does no light calculation, nothing, because I say this is just my sprite shader. The only thing I wanted to do is I wanted to be able to draw this 2-dimensional image, put it into my 3D. The only thing I want to be able to change is its texture, which is the color, and its opacity to make it see-through. And that means my sprite shader can draw, many different images to get these kind of things going. I'm wondering if I'm forgetting anything in particular. I was talking about doing fog. The main thing I want to say here is there's one thing I forgot when I did it in the lecture, which was to check if the fog, like if the distance is less than the fog start distance, then obviously we just use the whole color. And if it's higher than the other fog distance, we can just discard it. In the lecture, what I did in the fog was I simply always made the ratio, but that meant the ratio could become a number lower than 0 or a number higher than 1 because it didn't set boundaries as well. That's something we have to make sure we do in the fog as well. To begin with, check, is it actually closer than the fog start? In that case, we just use the color that we have. Is it further away than the fog end? Then we just take the fog color 100%. If it's in between there, then we do what we did and kind of mix the two up. Yes?
I was wondering, how would you use what you were using to make a sky?
A sky? Okay, so there are basically 2 main ways to do a sky box and a sky sphere. So a sky box is simply a textured cube where you just watch basically the insides of the box. So that's a sky box. A sky sphere is the same thing. You texture a sphere and then you just put it around everything. You imagine that a sky sphere is so far away that kind of moving around doesn't affect how you see it. Does that make sense? So it shouldn't really be affected by you kind of moving to the sides. So you can actually take your sky sphere or sky box, and it doesn't actually have to be bigger than the surrounding, how you say?
Than the environment.
Than the environment.
Just bigger than the environment you see.
It doesn't even have to be bigger than the environment you see. Instead, you can simply switch off depth testing when you draw the sky sphere, then switch depth testing back on when you draw all the other stuff. So you could actually draw a sphere always just around your head. Let's see if we can get this to work. If we just draw a sphere, I'm wondering how we can flip the normals. I would actually make a new shader for this, just for this, because you don't want any lighting calculations on this. You want it basically to work like the sprite shader. Come to think of it, if we would draw a sphere into the sprite shader. So let's go into shaders. No, not shaders. Into base 3D objects. Let's take our OptiSphere here and let's add okay, let's just make a sky sphere. Let's make another operation here. Let's call it sky sphere. Make a sky sphere. I am going to skip the normals which means I'm not going to do this twice. I'm not going to do this twice, right? But I am going to add the UV coordinates for both. Okay. So sky sphere, stack slices, we don't even need that many stacks and slices. So let's just default it much lower. Let's default it at something like 6 and 12. Just to see how that works. When we send this in, we build this, we draw, except we want to use a sprite shader here. Of course, this name doesn't matter. I'm just doing it to remind me that I'm using a sprite shader. We do all of this with a vertex buffer ID. But since it's the sprite shader, then we're sending something that has 1, 2, 3, 4, 5 per vertex rather than eight numbers per vertex. Otherwise, I think this should work the same. So we've got our sphere, slice interval. Okay. Let's go into our main program. I'm going to make, sorry, I'm going to go where I initialize things, find where I initialize my sphere, steal this. Okay, just going to put it here by the sprite. So I'm going to say this is our sky sphere. Let's just leave the default values. Okay, so my sky sphere is going to be a sky sphere. Now, we can actually use this to look at what happens if we use one shader. So blend, I'm not going to use none of this. I'm going to use the sprite shader. We need to set the correct values here. Sprite. All right, I'm just going to steal this. And I'm going to take it all the way to the beginning because I want to draw this first because everything else is going to go on top of it. And rather than using this, like using depth testing to decide that this is behind it, I'm actually going to just switch depth testing off for this. So here we do a lot of stuff. Okay, here I say shader.use, shader, model matrix load identity. I'm going to go in between here. I'm going to do this. But I'm going to take model matrix load identity and put that above everything. Okay, so now we have some basically different ways of doing this. We could actually have an identity matrix in the view matrix as well, and then just draw the sky sphere right there with so I could model matrix load identity. That means I get an identity matrix for it from it. So I think I'm going to go ahead. These are kind of tricks. Model matrix dot matrix. No, not the projection matrix. Sorry, the view matrix. Okay, so here is my model matrix. So I'm going to set an identity matrix to both the view matrix and the model matrix, meaning that I basically imagine that I'm just sitting right there in the center of the world and drawing this. Okay, no, sorry. There's one thing that is not good about that, and that is the fact that I need to make sure that the camera is rotated correctly, not only positioned. So let's do it like this. Let's set the view matrix. this is also a little bit clearer. So I set the projection matrix, I set the view matrix, I set an identity matrix for the model matrix. That doesn't work either because I need to, okay, always the same things we're looking for here. All right, cool. So I'm going to use the sprite shader, add a translation. Before I do that, I'm going to do self.model matrix dot push matrix. I'm going to end with pop matrix. Okay, I already have. Okay. Sorry. I already have this here. So the translation for the sky sphere is going to be self.viewMatrix.I. Did I have a translation that just took a point? Oh, let's do it like this. X Y Z. Okay, so I'm going to translate to where I am, and I'm going to draw the sky sphere around me. Let's just start with that. So I've set the sprite shader, set the opacity to 1, definitely here. I am going to set this texture to what were they called here? Earth Day, something like that. It's just Earth. So here's sprite shader use. So Earth, I'm going to set the alpha shift to none. Set the opacity to 1. Okay, so I'm going to translate to where the camera is. I'm not going to add any rotation, and I'm not going to add any scale. Set the model matrix. Then I'm going to say self.skysphere, draw. Right, let's just see what, there are probably things that I'm forgetting here. Okay, so now I'm inside this. You can look around, and this is kind of my distance, so to speak. Now I'm moving around, and it's not changing at all. I'm moving, it's not changing. So this is kind of silly. Let's see if we can find a nice skybox texture.
Sky sphere texture.
Oh yeah, that's true. Did it suggest that? Sky sphere textures. I guess something like this would work. Oh. Okay, this one. Let's take this one.
Then you can make it rotate so it looks like clouds are moving.
Yeah.
Slowly.
Yeah. No. Yeah. Okay. Not really. The whole thing would then be moving. You'd actually need to have an animation for
So
that to
you
work.
have specific for clouds.
Okay. Why did I not just? Can I somehow just view this?
Right click, view image in the tab.
Open image in new tab.
Old image.
Oh well, this is good enough for now. Save it. Call it Sky Sphere 01. Save it here. Go ahead up here and make a new texture. This. Okay, like so. ID sky sphere. Okay, so first thing we do, let's make this nice. Where am I? It is here. Okay, so this texture ID, let's have that the only thing we change. Okay, so we have this sky sphere here. But again, I'm moving around. I can rotate and I see the different parts of this. When I move around, it doesn't have any effect. So here's the trick. Before I do this, I'm going to go ahead and do GL disable, oops, caps lock on, GL disable, GL depth test. And after I do this, I'm going to go do GL enable. Another thing we can do, sorry, what did I do? Yeah, just G, okay. However, another thing I'm going to do, I'm going to take this line and look at it a little bit, because we can clear the color buffer bit and we can clear the depth buffer bit, but we don't have to do both at the same time. So if I want, I could say I'm going to start here by clearing the color buffer bit. If I draw things actually with depth testing, and then later on I want to say, okay, now I want this to be flat and everything I draw from now on to be on top of it, like I'm drawing everything closer. Or I change my near plane and far plane so they don't match up anymore. I can do GL clear, GL depth buffer bit at any point. So I can actually go ahead after I disable depth test here and say now I'm going to make sure that I don't want to clear the color buffer bit, then I'm clearing the actual frame buffer. But I can kind of restart or reset the depth testing. So I could say I don't really care about the depth buffer here to begin with, because the first thing I'm going to draw is something I'm going to use no depth test on, but then I'm going to clear the depth buffer bit afterwards. And now I'm still drawing this around my head at all times, but the other things, despite actually being further away, look like they're inside the sky. So the sky, see, I'm moving around and you can see that I'm moving around these boxes, but the sky, when I move to the sides, it doesn't change. So moving doesn't change the sky, right? Rotating does though. And that makes sense if you're looking at something that's so far away that kind of your position 1 meter to the side or 2 meters to the side doesn't really affect like the direction that the sun is in. I can point at the sun in one direction and then I can walk 100 meters, still pointing in the same direction because the sun is super far away. So that's kind of the way Skybox works. You can also just draw it with depth testing and make sure that it's bigger than everything that's in your scene. And that's something that feels often more intuitive to do. But I like this trick because you can just draw it wherever you are. You just, if you think about it, I'm drawing it small. It looks big, it looks like it's really far away, but I'm drawing it just around my head. I'm drawing it like 0.5 away from the camera. That's the distance that it's at. But it doesn't matter. If I then switch depth testing back on and draw everything else on top of it, it seems far away. Yes?
Do you have to concern yourself if you change the near plane?
In this case, no. But if I change the near plane, then depth values aren't comparable with the depth values that are already there, right? Because the near plane and the far plane affect. So if you're drawing things that are far away and then things that are closer, but you want to use your depth values as well as you can because you don't want to get z-buffer fighting, then in some cases you might say I'm going to draw everything that's far away first, my background things. And I'm going to have a near plane that's like 100 away from me and a far plane that's 200 away from me. And I'm going to draw the objects that are between 100 and 200 away from me. And then you draw those and you use depth testing and you use that near plane and far plane. Then you say, now I'm going to draw the things that are closer. So I'm going to set my near plane at 0.2 and my far plane at 10. I'm going to draw kind of the local things. If you're going to use depth testing on those, which you probably want to do because it's 3D, then you have to clear the depth buffer first. Because if you don't, you're using values that range from 0 to 1 or -1 to 1, from 0.2 to 10, and you're comparing them with values that originally were set with a near plane of 100 and a far plane of 200, but still range from -1 to 1. Still range. Do you get what I'm?
Still in the same buffer range.
Still the same buffer range, but it's a completely different kind of world range in your three-dimensional scene. So if you're going to change near plane and far plane, almost always you kind of render depth testing between everything you did before you changed the near plane and far plane and the things you changed after you changed the near plane and far plane. You can't compare those. Those aren't comparable. The depth of those isn't comparable. So in this case, I just switched off depth testing. So the sky sphere doesn't have any depth testing on, so it doesn't affect the depth buffer. So you can do experiments with this, like changing the near plane and far plane and then drawing things, but they'll be completely incompatible. Things will obscure other things that doesn't make sense. So if you're going to change the near plane and far plane, in most cases you have to clear the depth buffer and start your depth testing over. You don't have to switch off depth testing, but you have to clear the depth buffer. Okay, so here more or less everything is a little bit transparent.
I can see in the skybox, if you look down,
Yeah,
kind of like these, where the points meet,
yeah,
right where you're looking at now.
I know.
Could that be fixed with having?
So one way I could fix it is I could go ahead where I make my sky sphere. I can say I want my sky sphere to be more detailed. So let's make it, something like this. You still see that, this. Another way to make it better is just to have a better sky sphere map. Maybe the texture just
Bad texture.
bad or not bad. You're always going to get some kind of, you know what's happening there. You're taking the whole texture, you're taking the whole either upper or lower edge of the texture, and you're basically converging it into a single vertex, into a single point. So the polygons closest to this will kind of be taking texture coordinates, and kind of converging everything into one point. So yes, the bottom part of the texture, if we look at the sky sphere here, you're going to have to make it pretty good for this not to happen.
Yeah, I mean, if you're drawing it now, it happens below you. Is it because of the way you set it up, or is it just coincidence?
I'm not sure if this skybox is designed to be 360. It was just supposed to be.
Yeah, exactly. True, that's another thing. As soon as I would draw a floor and a ceiling maybe, or,
Could you do a skybox that's only, half of a?
Sure, I mean, you can just draw half a sphere.
This image is probably for half a sphere.
Yeah, it's upper half.
Yeah, that's true. So you can draw half a sphere. I mean, a simple way to draw half a sphere here would simply be to not draw the rest of it. No, wait, if we just, say, but then obviously the texture coordinates are still. So now I'm just drawing half a.
You would have to fix the texture coordinates.
Yeah, I need to fix the texture coordinates. I can probably take those and just multiply them with 2 is one possibility. Except not the x. Should do that with the y. Like so, and then like so. Wonder if this works. not, I think, what we were.
That's kind of the image.
Yeah, no, times 2 isn't good enough. Well, I want to go from 0
But yeah, the
to
top,
1.
it was the
Yeah,
bottom
yeah,
of the
yeah,
image
okay,
going
okay.
together.
Yeah,
We're going to
so
And you see the top of the image is where you brush.
exactly. So I'd like to do 1 minus all of this, possibly. I'm just experimenting now. I'm not, but let's see. Okay, this is more like what we're looking for, right?
Then you could have a floor.
Then I could have a floor, and yeah, I can look up, and if I have a floor, yeah, that extends into the distance, then that'd obscure this.
So you could do the same for land, sort of.
Yeah, you could have a different half sky sphere for your kind of land or your distance, or some buildings in the distance or something, and I don't know. You can go wild with this. But this is the idea of a sky sphere or a skybox. Is simply you're drawing something around you as your background, and then you draw the rest of your scene on top of it. And it doesn't, it moves with you. I'm moving all over the place, but the distance isn't moving. That's not always what you want. Sometimes you want it to move a little. You figure that out, or anyone who's doing this can figure that out on their own. So we have a bunch of blending here. We have this half transparent leaf here. Probably go in here now. Find my leaf again. Here. Not have it transparent. Right, but I think I've kind of gone through most of the kind of ideas here. There's one thing that I wanted to do that I talked about, which is particle effects.
Yeah, I was about to ask that, like fiber or something.
Yeah, we can still do that. It takes a little while. It'll just add to the time here, but I'm just wondering if there's anything that you missed just of general methods here. We've looked at blending. We've looked at how we can use that to get different effects. Well, not different effects, actually, only the one effect. So let's look at different effects on that now. Using textures to do a skybox, using textures, blending, splitting up shaders into different shaders that do a particular thing, so you don't have to have all these different variables and all these different if sentences in each shader, but instead just taking shaders and making them do exactly what you want them to do. Just make sure that when you switch to it, you set all the variables that it needs. So I wonder if we put this in base 3D objects here, or if we let's just make a new file, call it particles.py. Import, let's say from base 3D objects, import everything, class particle effect. So just to get this started, particle, what is wrong with me? Particle effect, particles. In itself, let's begin here. Particle effects, can make something super simple to begin with. But with particle effects, if you want to make a general particle effect, you end up with a lot of variables. Like how fast do things emit, how many particles are there, how long does each particle live, in which direction does it move, does it fade out, does it disappear, does it shrink out, does it fade in, does it kind of grow in, all kinds of things. So let's just start with something fairly simple here. So we need an update function on this, and we need a delta time update function, and we need a update. We need a draw function or a display function. Wonder if we need a shader for that. Okay, so what do we need to make a particle effect to begin with?
Probably some images.
Sorry?
Probably some images.
Okay, we need some kind of texture for it. All right, let's just say it holds its own texture image ID, but it's something that it's sent into it. Let's say we need to send into it texture. So self texture equals texture. It needs a position, I guess. Position. Actually, we can go ahead and say this is something that needs to be sent in as well. Position. So let's start here. Let's say just update does nothing, but what draw needs to do well, we can just allow it to make its own sprite. But the idea is that sprite is a generic class. We could actually just have one instance of sprite and send that to, basically use that to draw everything. Let's say we make sprite here. So in draw, we would like to do basically what we do here before we draw the sprite. It's just, well, no, not this. Let's imagine that we get the sprite shader and it's actually set. I guess we need to take blending as well. Okay, let's take all of this and say, okay, we're going to skip some of these things. This sprite shader use. So active texture, texture 0. We're going to set our own texture to that. Self texture. Let's just say that we don't use any alpha texture. We might very well want to set opacity. Set that to 1 to begin with. All right, let's just add a translation to our position. X position.y position.z. Okay, let's skip the rotation for now. Let's actually comment out the rotation and comment out the scale. Set model matrix. Draw our sprite using the sprite shader that was sent in. Okay. Fire particle texture. I was hoping we could find just an image of a single particle rather than an image of the effect. Now let's use this. That's all right. In many cases, actually, where is open image in new tab? Texture images need to be like their edges whole powers of 2, so 128, 256, so on and so forth. I have a feeling that this version that I'm using of OpenGL kind of fixes that. Let's see. So to begin with, we have a fire particle. Let's go in here. Make one more of these. Fire particle .png. Texture ID fire particle. Okay. Let's go ahead here and do self.particle effect equals, oh, I have to import that. From particles, import everything. Okay. Particle effect. And I need to send him some position, so point 4 -4 0, and we need to send in a texture. Of course, we could also have the particle effect itself kind of make the texture, but in this case, if we're using the same particle for different particle effects, it's better to load it outside and then just send the ID in, so we can reuse each one as much as we possibly can. Now I want to simply go down here into where we're drawing things, where we've already set our sprite shader to be used. Just go here and say self.particle effect.draw sprite shader. No, self.sprite shader. Let's see if it draws something.
But you have to pass in the model matrix as well because you're using it in the draw function.
Ah, yes. So let's look at the draw function again. So yes, we're using, to begin with, we can't use self.spriteshader. And we need a model matrix in here, that's true. Sprite shader, model matrix. Okay, this is correct, not this. Okay. Let's close some of these here. And it matters that we send in the model matrix rather than doing the changes outside, because we have to do changes for every single sprite in our particle effect in the end. Let's just make sure that this draws to begin with. Takes 3 positional arguments. No, 2, but 3 we're giving. Oh, I forgot self. Same here, update self delta time. All right, here it is. Okay, that's not a great place for it. Let's have it closer to where we are. Means, so where did I put it originally? Here. So higher and closer. Let's just not have it to the side. Let's see where this leaves it. So there's a lot of things happening in the loading now, so it takes a while to start the program. All right. So this is it. So there are things that we'd like to fix here, right? Obviously, to begin with, we want to lose this edge here. Can anyone propose a way to do that? So we're not sending in any alpha texture. And I actually don't want to do that, yes.
Just anything that is completely black, fade out.
Okay, so we want the black to basically represent opacity as well. That is, I want it to be completely transparent when it's completely black. So I somehow want to blend it like that. I can actually make blending do that. In that, what we've been doing in blending until now, okay, we have the blend here, is we've been saying I want to use source alpha, but I want everything behind it to be 1 minus source alpha. So if this has full alpha, I'll draw this, but whatever's behind it will be kind of diminished as much. However, I want to go ahead and say here, I just want this to be whatever it was. Whatever was there before, the destination, I just want that to be multiplied with 1. I just want to leave it there. That means if I add a black color, which is basically I'm adding the value 0, 0, 0, I just want it to be added on top. Which means a black color has no effect. So now it looks like this. And if something's behind it, no, it's just this basically. So it looks kind of silly with the sky behind it, but it's kind of powerful on the black background. But if we go half and half, you can see that it's not kind of a big black box there anymore. All right, so we just have a different blending policy here. Now we want to start doing something like adding more particles, right? So what would a particle need in a particle effect? Let's imagine I'm going to be calling update here.
You need many particles.
Okay, I need many particles. So self.particles, what would self.particles be?
Array.
Could it just be a list? But then we have to think about what a list of what is it? So should we make a class called particle? So what should a particle have? It should have its own position relative to the position of the particle effect. It should probably have its own direction or motion. So some motion effect. I don't know, should it have its own size? Should it have its own... Let's start with position and motion. So self dot, let's just say pos equals position, self dot, something like that. Okay, so now the question is, should we have the update function here just use these variables, or should we actually have the particle itself have an update function as well? What do you feel better with? It doesn't matter, we can do both, or we can do either. Like, would you want each particle to update itself and draw itself, or would we rather just our main update and draw functions talk to the particles?
Probably the main.
Okay, so we don't have to add to the program stack. I guess it'll be a little bit better optimized if you just have the main, or this update function talk to the rest. All right, so Now the question is, what do we want to do in this update function? We want to go ahead and do something like for particle in self.particles.
You want to add motion to the position.
Yeah, okay, so particle dot position plus equals particle dot, no, not position, it's pos. We wanted this to be shorter. Direction times delta time.
We had motion and direction.
I called it
Ah, there.
there. I called it pos and dir inside here, but anyone using this will see position and motion. Not that it matters because this is the only class using it. I just wanted it to be a little bit shorter. Okay, so we can do something like this for every particle. But we need to kind of add particles, right? We need the particles to become new particles. So how can we do that? We probably need
Make
like how many do we want to make? And do we want to have that a variable or do we want to just hardcode that? We can hardcode that to begin with. So do we want to make, let's say, 10 per second? Okay. But how can we kind of keep track of delta time? Like to make sure we make 10 per second. If we just check delta time and say, like for every 0.1 that delta time is, we make a new particle. We'll make no particles if delta time, if we have a frame rate of above 10 frames per second, right? So we kind of need to accumulate that. So we'd like to have something like self dot time since particle. Does that make sense?
times.
That's what's created.
Yeah, time since particle was created. Now I want to go ahead and say I want to go ahead and say self dot time since particle plus equals delta time, right? So I'm adding this delta time to it. Then I want to say
Don't you need to do
Then
part?
you did it, either you defined it in the wrong place or
Yes, self.time since particle is in the particle, not in the particles class.
oh yes, true. So thank you. Okay, time since particle. So particle effect here, particles here. Okay, so what do I want to do? While time since particle is greater than something, 0.1, because I want to make 10 per second. Yeah, it's self, true. Okay, then I want to do self dot time since particle minus equals 0.1 and self dot particles dot append particle. So now I want to give it a position. We say just self dot position.
self position for this.
Yeah, we'll start in the center.
It'll start in the center. Maybe we have to somehow make sure. Should we do it like this?
Would it be point?
Yeah, it should be point, true. But do you get the difference? So I don't actually want it to be the same. I want to make a copy of it. Something like that. So I'm going to send in my position. Let's just make it super simple here and say this is going to be a vector of 0, 1, 0. I don't know what's going to happen exactly here.
Don't you want to put on a limit
On how many there are.
or
Let's see if this works to begin with. Yes, obviously, if we're going to append a lot of them, and keep this going,
We also need to fade out.
we need them to disappear. And when they disappear, we don't want to just append and append and append. We want to actually reuse the spaces where dead particles are, things like that. Let's start with this, though, just to see if this works. We just make a new particle every 0.1 seconds. We append it to here. That, though, means that we need to draw differently. Again, we use the same blending, we use the same active texture, all of that is the same. Set opacity, we want all of this to be the same. Push matrix, translation to self position. Okay, we want to add that translation, but then we probably want to go ahead and push again. Pop afterwards. And add all of this into a loop that is exactly the same as this loop for particle and self particles. But we are now going to add another translation, right? Add translation, except this is going to be particle dot pos x. So there. Does this make sense? Nothing, okay? Not quite we envisioned.
Oh, are you drawing it in the Control 3D program? Very good, very good.
Yes, I was earlier. I think I realized what was wrong here, at least one thing that's wrong. But right at the bottom of the display here, we're drawing particle effect draw. Okay, because originally we drew that single particle and that was through the particle effect. What am I doing wrong here? When I'm updating them, I'm actually setting them to the position I'm at. So it's not a relative position, it's actually a absolute position, right? So I was treating it as a relative position here because I first translate to this position, then I also translate to this position. Another thing I'm probably not doing, am I setting the model matrix? No, I'm setting it too late as well. So I should actually do this. I should skip this. For whatever reason, it still wasn't drawing. Okay, again, nothing. Sprite draw using the sprite shader. We've set the texture the same way as before. We've set the model matrix. Are there no particles? Ah, yeah. What am I not calling in Control 3D program?
Update.
I'm not calling update. So let's go to our update function here. And we'll go ahead here and say self.particle effect.update delta time. Or is it self.delta time? No. Delta time is new every frame. Okay, so we need to update it and we need to display it. And now we'll see if anything is happening. Okay, there's a single particle there. Is there nothing else? Okay, so how are we making them?
No, you're doing it like creating it to your position, right? So if you go back all the time, you might see one.
Let's see, I'm creating it to the position of the particle effect. But the particle effect itself should not be moving, right? See, and I'm sending in some motion. It was moving up. Just seemed that I only ever made one. Okay, I said time since particle plus equals delta time. If it gets bigger than 0.1, it's making a new point here. So when I'm updating each one of them, okay. So it seemed like there was one there and it just moved up. Okay, let's do something else here. Let's just, every time I update, let's append one. So I'm going to take this, and I'm just going to skip this whole time since particle thing. So we're just making one every frame. It's going to be a lot of them, but you know, can hopefully handle that. Still, just the one. For particle in self particles, I update.
It's like you're only drawing one.
Is that now for particle in self particles? I'd like to imagine this is the same list. We can try something like print something like that, just to see. It's growing constantly with every frame.
Are you maybe not making a new particle, but instead just compare to the same particle again and again?
I mean, this is just Python code. This should just work, right? And I thought I was not kind of copying the same position over and over again by making sure that this actually does this. Okay, where are we going wrong here? Delta time. Do we need some random factor here?
No, because there's always.
Is the translation maybe moving in the same speed as...
Are we not pushing and popping? Yeah. Add translation. Model matrix, add translation. Then we set the model matrix, then we draw the sprite. What happens if we draw more? I think it should become brighter because we're just loading it on top of the other ones. Okay, let's set the motion to 0. Like the motion that I'm adding here. I was going to make that more random so it goes kind of all over the place, but to begin with, let's... I'm wondering if it's drawing more than one here, because everything is getting slower and slower.
position particle that moves with the particles.
Yeah. So they're always being created. Yeah. Equals a point with these values. How can these be?
Could it be
Seems like I'm always changing the same position. But it should go faster and faster if I'm doing it for more particles every time. Add translation. These kinds of things drive you mad. So one thing I wanted to do is to go ahead and do GL disable GL depth test and enable it again after I draw the because I want to see if this is kind of being constantly okay, you can see there are a lot of sprites there. It's not just the one, they're little by little. Okay, so it is making a bunch of sprites, it's just not moving them. So again, I want them all to get this vector. Okay, I want to take this and say just process position. I want to go ahead here and say I'm gonna take this and say I want this to be a point. Let's just go back to saying I'm just going to make this point 0, 0, 0. And I'm going to have it relative. So I'm going to go back in here to first translating to the position of the particle effect, then to each particle. So I'm making a new point here and a new vector. All right. Now it's doing what we wanted to do, sort of. Or it's making a laser up here. Okay. But obviously what we want to do now is kind of randomize a little bit the directions that it goes into. So, all right. Now you kind of have to help me out here. We want to send them randomize a little bit where they are no, rand.
This is random, not from 0 to 1.
Okay, random. Okay, that's from 0 to 1. Yeah, let's just leave it at that. I guess we could multiply that with whatever. So here, and we want this to be random minus 0.5. That means if it's from 0 to 1, it'll be from, okay, like so, and have this random plus 1. Okay, let's start here. Now we've randomized a little bit where they're generated, and we randomized a little bit the direction that they go in. Okay, so now they're going all over the place. But still, this isn't really what we're looking for in a particle effect. So to begin with, let's slow them down a little bit.
You don't want the picture always to be facing the camera.
That's another thing that we need to think about. Like, can we take each of the particles and have them facing the camera, or the entire particle effect and have them facing the camera? Yes, we can, but then you have to take a vector from them to your position, and you basically have to find the rotation needed to line kind of a normal to their front face up with that. To do it for every single particle might be expensive, but to do it for the particle effect, maybe not so much.
Could you not utilize eye coordinates?
To draw them into eye coordinates, or to look at, like, not rotate the view matrix or something like that?
Have a separate matrix that has none of the rotation.
Yeah, none of the rotation, but only the position of the view matrix. Possibly. I'd recommend you go ahead and kind of figure these things out. I'm not sure I have time to go into that. I'm going to slow them down a little bit here. And we need some way of killing them. We need to give them some kind of time to live. Okay, so what did I do wrong here? Oh yeah, I can't do it before. If I want to multiply a vector, I need to do it afterwards. So now they should go a little bit slower. Maybe we should skip drawing the sky sphere while we're doing this. Okay. Not quite a fire yet. So they're pretty big. We probably want them to fade in and fade out, right? And we want some time to live. So let's start with the time to live. So to begin with, how many particles are created? We should try to get back to our original idea here. We're going to take this and apply it here. But now I want 10 per second rather than 1 every frame.
Maybe looks about right.
Okay? And even though the frame rate is slowing down, the rate of particles is not slowing down. Because, yeah, before it just means that more per frame are being added. Okay, so we need to kill them now. Also, we are using here 0.1. Instead, we might go ahead and do something like rate. Say self.rate equals rate. And instead of 0.1, we say self.rate. You can also have default values for this. We can have time to live equals, or say 2 seconds. Self.time to live equals time to live. Okay, how can we incorporate this in the update function? We probably have to.
Each particle maybe knows how long it's been living, or
Yeah.
keep track of it.
Okay, so we need to say time lived here. So self.time lived equals time lived. And we need to check that for the particles.
Can that be just in the initialize just be by default 0? You have to set it.
Oh, that's true. Don't even have to have it like that. We can just say it's 0. True, thank you. So, regardless, we want to go ahead and say particle dot time lived plus equals delta time. Since this frame, it has now lived delta time longer. If particle dot time lived is greater than self dot time to live, then we need to, well, then we need to not update it. We somehow need to
Add it to another
kill it.
array or something. Because you can't kill it.
We kind of need to throw it away. But we also want to free up the space so that we can put other things in there as well. So we don't, so the list doesn't just grow in. Or how does remove work in Python? Can I just remove?
I don't think you can remove while you're looping through that arrow. Maybe I'm wrong.
Ah, yeah, I see. See what you mean. So we can make a temp list. So I can say particles to kill equals a new list. Then we can go ahead and say particles to kill dot append this particular particle. Okay? And then we do the other stuff. Should we then go ahead? I'm always thinking about the time complexity here, because if we remove it, it's actually kind of shifting everything in the list, which is probably not going to hit us very bad. But we could also kind of make that space in the list none, and then kind of read through it and add them to there. To begin with, we can optimize later. You can optimize later. And kind of try to reuse the spaces that you're killing particles in rather than shifting everything every time. But so what do we do now? For particle in particles to kill, self.particles dot, what's the operation? Remove particle. So this should be the same object, so it should work, right?
Yes.
Okay, so now we're saying time to live is 2, rate is 0.1. They should now all disappear after 2 seconds. I was going to take the skybox out. Okay, so they're being created and they're being removed. I am going to go in here and I'm going to stop drawing the skybox. Or the sky sphere, which is at the beginning. I'm just going to take this entire thing. See if I can comment that out. Okay, so a particle effect is now there. None of the other stuff is being drawn, so there's something more that clear depth buffer and enable depth test. Something that shouldn't have been part of. Okay, so we should put this fire closer to us though. No, I'm actually just going to go and see where we are. Like, where is this camera put in to begin with? So we are in 333, looking at 0.000. So if we put the particle effect in 222, it should be right in front of us. a little bit too right in front of us, but okay. Okay, so now it's emitting particles and it's destroying particles. What would we like to do?
Fade in, fade out.
Okay, we'd probably like to fade in and fade out. Possibly, we would like to go ahead and go in here, and this might be something that we'd also like to have a variable here, like how bright they are. But I'm going to allow myself now to just hard code it, but we could set that as a parameter as well. Like, what is the opacity? What is the base sprite opacity? They're still pretty strong, but the lower we put the base opacity, okay, I need myself to be a little bit further back and a little bit to the right. I'll set myself at something like this. Wait, where's the particle effect now? Did I put it below the threshold or something?
Is it open too?
I don't remember what I put the threshold at in the shader. We need to check that out. Okay. So we're randomizing it a bit too much as well, and that might be a variable as well, like what's the area in which it randomizes in? How big is that area? At this point, we're doing random here. Might want to do random times, and this might be a variable called something like area, like emission area. So I'm going to make the area a little bit smaller. Okay, and we want to fade in and fade out. So how are we going to do that? Okay, so this looks kind of cool. They're all being made here. It's lowering the frame rate a lot. Okay, maybe we'd like to spin them or randomize them in some way, but you can add that later. What we would like to do is to say, instead of, there was a hard-coded number I put in here, which was, wait, we have time to kill. Yes, okay, let's add something here and say opacity fade in time. Should you say one fade in time and one fade out time, or just a fade time?
Same.
Is it okay if it's the same?
Yeah, sure.
I think in some cases it would be nicer to have it. Okay, so let's call it fade time. So we have opacity and we have fade time. And I'm going to set opacity here to opacity, but that's not really what I want to do, right? This would be self.opacity. So we need to go up here and say self.opacity equals opacity. Self.fade time equals fade time. So this is the last thing we're going to do, because I have basically stood here the entire time programming. I'm not even going to apologize for it, because there's just so much fun stuff that we can do. I know it's been less of a work class for you and more of just me programming here, but
Something we can use.
hopefully something you can use, hopefully something that can give you ideas. Anyway, the last thing we do is going to add this fade time. So now I'm just setting opacity to self-opacity. Opacity, classic. That's what my fingers want to do. So what do we want to do instead? Right now, let's just make sure this compiles. Now I want to calculate this opacity because like during the middle of a particle's life,
You just set default values.
yes, exactly. Or actually I don't want to set default values, I want to force anyone who uses this to actually set values here. So this is going to be opacity. So opacity is 0.2. Actually I want to go into the shader, sprite shader, fragment shader, and I don't want this to be so big. I want to throw something away. Or this should actually be some kind of variable, this threshold value. I'm not going to set it like that right now, but I'm going to make this much smaller. So let's imagine that you just set a threshold value for your sprite shader. So in this case where we want these really, really dim particles that then add each other up into a light effect, energy effect, we want to do this, but in the case of something like the leaf that we were drawing, we might want to have a higher alpha threshold. So I'm not going to waste time now setting an alpha threshold value. So time to live. Okay, actually, let's set this as a default value. So I want opacity here, but sorry, save particles. Let's go up here and say, okay, yeah, each particle has opacity and a fade time. We can say, wait.
You have to make it in the particle class.
Yeah. I have to, well, no, not really. So the thing I was thinking about was rate time to live. I'd put fade time behind that, kind of in the order here. So let's just say fade time is, let's make it fairly long now, 0.3 seconds, so we see the effect. And then I'm forcing opacity here. All right, so now I'm just setting self opacity. And again, I'm going to make sure this compiles. And then we want to set up some kind of calculation for opacity, using self opacity, but also using, okay, so this is what it looks like. And then they just disappear up there. So now, instead, I want to say some variable opacity equals something, and then I want to, there. So in some cases, I just want it to be self-opacity. When is that?
In the beginning, maybe?
Not in the beginning. Self-opacity is the full opacity during kind of the main part of the lifetime of a particle. So if I'm not inside my fade in or inside my fade out, I want opacity to just be self-opacity. So how can I set up an if sentence that checks, am I inside my fade in? Remember, I'm inside, sorry, I should be inside,
Update.
no, not inside update, I should be inside this loop. So I should be inside this loop because I need to set opacity now not for the particle effect in its entirety, but for each particle. All right, so how can I set up an if sentence that asks me, am I inside my fade in? What do I have access to in the particle? If particle dot time lived is in what range? Less than self dot fade time. Does that make sense? So if I haven't lived to the fade time, that probably means that I'm still fading in, right? I haven't even lived to the fade time. So now I want a number that is 0 when I've just been created, just been emitted, but 1 exactly at, or actually self.opacity exactly when I've lived up to fade time. So how do we set up this kind of ratio? We've done it a lot of times. Like where I'm now minus where I started, divided by where I end divided by minus where I started. So x minus start x divided by end x minus start x. So where I'm at now is my particle dot time lived, right? Particle, okay, I could say minus 0, but that has no special effect. Okay, so how long have I lived divided by self.fade time. That's fairly simple. If I've lived up to fade time, this will give me a 1. If I've lived longer than fade time, I won't be in here. If I've lived 0, then this will be 0. Everything in between will be a ratio from 0 at 0 up to fade time at fade time. Oh, sorry, up to 1 at fade time. So I need to say it's this times self.opacity. Because I need to make sure that that is kind of my base. I go from 0 up to that, not 0 to 1, 0 to my base opacity. Fine. Else, how do I check if I'm inside the fade out?
If particle time lived is particle time lived minus what fade time?
Okay, if particle time lived minus fade time, or I could say if particle time lived is greater than time to live, which is minus self.fade time, right? So I'm basically saying how long will it be allowed to live in total minus the fade time, which if we want to have a separate fade in time and fade out time, then that will be fade out time. If it's greater than that, if I've gotten further than that, I know if it's even greater than that, if it's greater than time to live, then it should have been killed at some point, so I shouldn't be there. All right, so if it's greater than the total time to live minus fade time, so it's gone into the fade out. Now what do I want the opacity to be? Again, a similar thing, except now I want to say time lived minus basically minus this. Just gonna switch between lines here. Okay, so I have particle time lived. I'm gonna make another of these here. Okay, so the time that I've lived minus, this is kind of the threshold. This is the threshold time where I go into the fade out, right?
You have an extra parenthesis because look at the self.fade time.
Yeah, but I want the extra parenthesis to be able to switch between lines, because Python I think only allows me to switch these things between lines if everything's inside a parenthesis. Or is that only string things? Not sure. But there is an extra one, that's right, because I'm missing one basically here, because I need more. Okay, so this is the part. This is how long I've lived minus minus kind of this threshold, which is the whole time to live minus fade time. Then I should actually, in the end, divide that by self.time to live minus self.time to live minus self.fade time. But that's just fade time. So it would be kind of the end, which is time to live, minus the threshold, and this is the threshold. But if we look at that, self-time to live minus this thing ends up just being divided by the fade time, or fade out time. And then, so this parenthesis is for that one. This one here. Let's make sure everything is enclosed nicely in parentheses here. Okay, I guess we have an else here, which would be I'm not inside the fade in time, I'm not inside the fade out time. That means I'm somewhere in between them, because I wouldn't be created yet if I was before the fade in time, and I've probably been killed if I'm after the time to live. So this should leave me there. Okay, so fading in is working. Fading out, not so much. Why? You can hazard a wild guess. Can you see what's happening? Like, look at it. Can you see what's happening?
Fading out very quickly, right for the end.
It's disappearing, fading in and disappearing again. Like, what does that tell you? Around here, they disappear, then they fade in and then disappear again.
The math is off.
Yes, my math is off, but there's a very particular thing that's off with my math. And it's a thing that you could, I would just go ahead and guess. I would just guess and put something in there and hope it gets fixed, but I know exactly why this is happening. Like, it's fading in a different direction. It's doing the fade out time, but instead of going from 1 back to 0, it's going to from 0 to 1 during the fade out as well. So the fade out is going in the same direction as the fade in, which means that as soon as it hits the fade out time, it disappears and fades in again and then disappears because it's killed. So one thing we could just do is hazard a guess and say, wait, don't I just have to take this and do 1 minus it? Like, sure, I could do that. Do this and do 1 minus this, and that'll probably work. It's going to work. But I could also kind of flip this and say I shouldn't have done this minus this. I should have done this minus this. Either way, let's at least see it work. Whoa, that was even worse. Okay, so that was not it. Not that simple. Oh, it was supposed to be here. They became even brighter because I had the 1 outside the parentheses, so suddenly they were just hopped up to 1 instead of 0.3. Let's see if this works. There. Fading in, fading out. Okay, now we might want to have a shorter time to live or something like that. So the coolest thing to do now in experimentation, I'm sorry, way over time here. No, not way over time. We're exactly at time now, right? I think it's 1650 in the schedule. So this is the point where we start experimenting. We've got kind of the basics. It's emitting. Now we start experimenting with things like, okay, can I make them smaller to begin with? And this could be this is one more thing that you'd like to have a variable. But I'm going to go ahead and, wait, where's my draw function? And
You're still drawing 4 at a time in the draw function.
how so? Oh, yeah. Ah, okay, cool. So let's see what that looks like. Then maybe they don't have to be as, maybe their opacity could be more. But anyway, their opacity will be less now.
You have to remove something. No, yeah.
Yeah, model matrix, scale, and let's scale them down. Let's make them all smaller. This doesn't matter, I guess. Let's make them all smaller. Okay, so they're smaller and they are dimmer. Okay, looks kind of cool. Now that we've made them smaller and dimmer, okay, for whatever reason, okay. This scale should actually happen after this translation, right? I want to scale each one of them down, not scale the entire effect down. All right. So yeah, like I was going to say, this is the point where we have the fade in, we have the fade out, we have the sprite, we have some opacity. Okay, this is kind of lame. But then we do the fun stuff. Now we start just poking around with the values. So rate. Wait, why is the rate 0.1? The rate should be, yeah, exactly. The rate should be, now we want to do like 30. We want to change the way the rate is. Okay, where do I check the rate? Now I'm going to say time per particle equals self.rate. This is right. True? So instead of self.rate, now I don't have to think the rate in how many seconds between particles, but instead how many particles per second. Okay, so now there should be more. Now there should be 30 per second. Maybe that'll slow this computer too much down, but you can look at what it looks like. Yeah, it's way too slow. Okay, they're too small as well, or the effect too. Okay, so now I want them a little bit slower. So we can go ahead here where we create them and say times. So let's make them go slower. They are now, okay, yeah, we can make a variable out of all of this. We can go ahead and change the rate. We can change the time to live. Fade time, if they go slower, the effect should be more compact. Then we can do things like pulling them back in towards their own center. Okay, so this is a little bit more interesting. We like to have a longer fade in and fade out time. Fade time 0.5, rate 50. If it becomes too bright, if we have the computing power, sometimes rather than, basically if we feel it's the correct brightness but it's going too slow, we might make each particle brighter but have fewer particles. But if it's going fast enough, we might want to fade them more out, that is, or not fade them more out, but have the regular opacity less. So the original kind of the main opacity is less, but we have more particles. So if we like the effect, it's super slow now. But if we like the effect, we can do something like say, okay, I want my base opacity here. Why is it complaining now? So I'm going to say I want their opacity to be less, but I want to have more of them. Okay, so let's have the default rate something like 10. And so on and so forth. And then we can switch out the image, have different images. If you want to make an explosion, you'd make a particle effect that just for maybe a split second. Okay, this is pretty slow.
What's happening to the shine spot on the globe?
I'm not entirely sure what's happening with the specularity of the globe. We've changed so much in that shader, it's all over the place. So if you want an explosion, you can do something like this, except maybe for like half a second you emit really many particles, then you stop emitting them, and then you just allow them to go and get killed, emit them in all directions. Again, like was stated earlier, they all are going in the same direction. They're all facing in the same direction, which means that if I look at them from the side, suddenly they disappear. You could add a random rotation to them, so they're kind of going all over the place. So different directions will show you different sprites. You could also implement something that makes sure that they rotate towards you, so they're always facing towards you. There are ways to do this, using basically this, probably the base information of the camera like you were talking about, the view matrix. Or basically you could take a dot product of the vector towards you and the vector that they're facing, and you could use that to rotate their face, find an angle between them and rotate by that angle around. You could take their cross product, then you get a vector, and you could take the angle between them, and we know how to calculate that. Once you have these two things, you can rotate them by that angle around that cross product vector, and then they would face you. this is fairly expensive to do for every single particle, but to do for the particle effect, that'd be okay. And then the particle effect in its entirety would always face us. So that's one thing to do.
Now you're practically lagging with just one particle effect.
Yeah, I know.
So how would you try to optimize it so it wouldn't lag?
Run it on a better computer where I'm not kind of, I don't know. This is a fairly big particle effect. I've dumped a lot of particles in them. In order to optimize it, you'd need fewer particles or less blending. We can just look at an effect and say, okay, what if I instead say, I don't want to have that many particles. Those are too many. I'm going to have 20. But if I just have 20, the effect is going to be too dim. So then I take the opacity up. So let's see what it looks like. Like this. Okay, so I have fewer particles, so it's less impressive. Okay, can I then take each particle and say each of these particles is 5 times as bright? So I have 5 times fewer, or 1/5 of the particles, but each particle is 5 times as bright. Will that give me a particle effect that, in a distance, kind of impressive? Up close,
Not so much.
not so much. All right, could I now scale my particles and say, all right, since I had to make them fewer, I can scale them. I don't know, I don't have a we don't have a variable for that, but we could easily add a variable and say, okay, let's scale them up then. Double the size of each. Again, let's go ahead and make each of them a little bit dimmer. See what this does for the effect. You know, it's just tweaking things like this. Then we could do something like, okay, so this is fairly impressive. It's not that bad, but it's 1/5 the number of particles, so it's not lagging as much.
Yeah.
So it's just hitting a sweet spot. You can make super nice effects with millions of particles, each one of them really, really dim, because then they kind of more naturally light each other up. But it's gonna, yeah, you had a question. Like this is even better, I think, than the one that had the most particles.
Looks more like a fire.
Looks more like a fire. If you would make this kind of a grayscale image instead, you could make really nice smoke. In some cases, you'd like to have a different, you wouldn't want smoke to light itself up like this does. This is like an energy effect where we have blending, like our blending is GL source alpha GL1. With smoke, you might want to have regular transparency where you have GL source alpha GL1 minus source alpha. Again, this will look different than before because I'm also disabling depth test. So now each of them will kind of, let's see, maybe it'll be ridiculous. No, now I can see the boxes around them. That wasn't what I was looking for. Yeah, I can see how. So yeah, figure out ways to kind of, like, if you want to do smoke, not have it actually, because GL source alpha GL1, it means the color of each one of these particles is added to the color underneath. So the more you have, the more energy you'll get, the brighter color you'll have. Anyway, go wild with this. Yeah, sure, it looks like fire, but at this point with particle effects, you know, you have the base. Go ahead and experiment with the values. Other questions regarding this? I hope you can use some of this. It's an insanely long video, and you kind of have to jump through it to find different tidbits. But yeah, I was just excited to kind of at this point get all kinds of things that we can do with blending and do with our shaders and splitting up the shaders and all of that. So I just decided to come here and do all of that in front of you. And I hope it hasn't been a bad use of your time. Question?
Would it be possible to sort of unionize multiple objects so that they have the same phase property, if that makes sense?
Yeah?
So if you looked through two boxes, so one box behind the other, if they were unionized, you could not see the second box. do the other one. Else you would.
Yeah, okay, so just these particular boxes are somehow kind of linked to the others, to the other one. I guess that's something you just have to do kind of in your own program code. I'm not sure it's something you could like do in OpenGL if you'd. Yeah, it just has to do with in which order you draw things and whether you're using depth testing and whether you're using blending each time. Like if you can decide these two boxes kind of don't affect each other in this way, but if they're not linked. Am I understanding you correctly? I have a feeling this is something that is just a policy that you would have to write in your own code before you send everything into OpenGL.
So it's a weird idea.
Possibly. But I don't want to dismiss things as weird ideas. Everything that you can kind of think of and say can usually be done. Some of it is complex.
It's related to the idea of four-dimensional maze, a fade-in feature.
Ah.
Because you don't want to be able to see the whole maze
Yeah.
at the same time.
Yeah, just the linked boxes, kind of the boxes that are the same box but in different dimensions, something like that. Never mind. Are there other questions here? Thank you for today. This was my last programming session. Next Monday we'll just look at a bunch of cool stuff that you've done over the semester. And next Friday will be more of a recap, doing exercises and answering questions and looking at old exams and kind of an overview of the pipeline, just taking everything we've learned in the entire semester and trying to boil it down to a simple structure and what you need to learn for the final exam. So yeah, cool. See ya.